Okay? Yes. For all n greater than or equals k. Agreed? Therefore, what this equation 1 implies, therefore this implies modulus of equation 2 implies modulus of xn minus xn, it is less than or equals, listen, what is modulus of x2 minus x1? It is strictly less than, yes, epsilon into 1 minus c divided by c power n minus 1, that is modulus of x2 minus x1 into what, c power n minus 1 by 1 minus c. Agreed? This is because from here, what do you get? Modulus of x2 minus x1 strictly less than epsilon into 1 minus c by c power n minus 1. So that means modulus of xn minus xn strictly less than epsilon for all n comma m greater than or equals k for n, that means secant xn is a Cauchy sequence. So from here we can conclude that every contractive sequence is a Cauchy sequence. Agreed? That is immediately from its definition. The sequence xn is contractive means modulus of xn plus 2 minus xn plus 1 less than or equals c into modulus of xn plus 1 minus xn for all n following n, where the c lies in between 0 and 1. Agreed? So this theorem states that every contractive sequence is a Cauchy sequence. Agreed? Okay. Now we prove another result. If x equals xn is a contractive sequence, there is another theorem. If x equals xn be a contractive sequence, this is contractive. With a constant c, means c lies in between 0 and 1, let limit x equals x star and limit x equals x star. Now there are two results. First one, modulus of x star minus xn. Modulus of x star minus xn less than or equals c power n minus 1 by 1 minus c into modulus of x2 minus x1. And the second result is modulus of x star minus xn, modulus of x star minus xn less than or equals c by 1 minus c into modulus of xn minus xn minus 1. So come to these two results. If x equals xn is a contractive sequence, means modulus of xn plus 2 minus xn plus 1 less than or equals c into modulus of xn plus 1 minus xn, where c lies in between 0 and 1. Let limit x star, means limit of the sequence xn is x star. Now we show the two results. X star minus xn less than or equals c power n minus 1 by 1 minus c into mod x2 minus x1, and mod x star minus xn less than or equals c by 1 minus c into mod xn minus xn minus 1. First part is immediate. Why? In previous theorem, the proof of previous theorem, we see that modulus of xn plus 2 minus xn plus 1 less than or equal c power n into that one. Also we see that modulus of xn minus xn, modulus of xn minus xn less than or equals c power n minus 1 divided by 1 minus c into modulus of x2 minus x1. Okay. In the proof of previous theorem, we see that modulus of xn minus xn less than or equals c power n minus 1 by 1 minus c into mod x2 minus x1. So letting m tends to infinity. Letting m tends to infinity, what is limit xn? It is x star. So it is modulus of x star minus xn less than or equals c power n minus 1 by 1 minus c into modulus of x2 minus x1. So first part is finished. That is immediate from the previous theorem. Previous theorem says that every contractive sequence is a Cauchy sequence. Okay. Yes. How to prove the second part? Modulus of x tan minus xn less than or equals c by 1 minus c into modulus of xn minus xn minus 1. How? That's also followed from the previous proof. How? You can consider for m greater than n, what about the modulus of xm minus xn here? Mod xm minus xn less than or equals, like in previous arguments, modulus of xm minus xn less than or equals modulus of xm minus xn minus 1 plus modulus of xm minus 1 minus xm minus 2 plus etc. plus modulus of modulus of xn plus 1 minus xn. Okay. Since xn is a contractive sequence, secant xn is contractive, modulus of xn plus 2 minus xn less than or equals c into xn plus 1 minus xn. So, modulus of xn plus 1 minus xn, modulus of xn plus 1 minus xn less than or equals c into modulus of xn minus 1, where c lies in between 0 and 1 since c is a contractive sequence. Agreed? Assume the result is true for k equals p. For induction, the result is true for k equals p means modulus of xn plus p minus of xn plus p minus 1 less than or equals c power p into modulus of xn minus xn minus 1. Suppose the result is true for k equals p. Now to prove the result is true for k equals p plus 1. How? To prove modulus of xn plus k minus xn plus k minus 1 less than equals c power k into mod xn minus 1. We use induction hypothesis. Assume the result is true for k equals p. Now to prove the result is true for k equals p plus 1. So consider modulus of xn plus p plus 1 minus of xn plus p. Okay. It is less than or equals c into modulus of xn plus p minus xn plus p minus 1, since it is contractive. What about this one? So it is less than or equals c into c power p means c power p plus 1 into modulus of xn minus 1. Hence the result is true for n equals p plus 1, k equals p plus 1. Therefore, the result is true for every natural number n. That means modulus of xn plus k, every natural number xn plus k minus xn plus k minus 1, it is less than or equals c power k into modulus of xn minus 1 for all k falling n. Enough? Okay. So, modulus of xn plus k minus of xn plus k minus 1 less than or equals c power k into mod xn minus 1. Then for m greater than n, what happens here? Modulus of xn minus xn less than or equals modulus of xm minus 1 plus modulus of xm minus 1 minus xm minus 2 plus etc. plus modulus of xn plus 1 minus xn. Agreed? So you can apply this result. But xn plus k minus xn plus k minus 1 less than or equals c power k into mod xn minus 1. What do you get? So it is less than or equals, modulus of xm minus 1 less than or equals c power m minus n. Agreed? So it is c power m minus n into mod xn minus 1. What about the next term? It is c power m minus n minus 1 into mod xn minus 1. Agreed? So for m greater than or equals n, modulus of xn minus xn less than or equals, by using this result, less than or equals modulus of xn minus xn less than or equals, first term is mod xm minus 1, xn plus k c power k. So it is xm minus 1 means it is c power m minus n. Agreed? So it is c power m minus n into modulus of xn minus 1 plus next term mod xm minus 1 minus xm minus 2, it is less than or equal c power m minus n minus 1 into modulus of xn minus 1. Agreed? Plus etc. Plus whatever the last term plus c into modulus of xn minus xm. Okay? Yes. So which is equals modulus of which is common here? Modulus of xn minus 1 is common. Taken outside. It remains 1 plus c plus. Sorry, it is modulus of xn minus, yes, xn minus 1 into, not a 1, it is c. It is c plus c square plus etc. plus c power m minus n minus 1 plus c power m minus c. Okay. So, it is less than or equals modulus of xn minus 1 into, you can introduce 1 here, 1 plus c square plus etc. plus c power m minus c. Sure? This inequality holds. So it is also less than or equals modulus of xn minus 1 into 1 plus c square plus etc. for an infinite series. What is c? C is any real number lies in between 0 and 1. So the term inside this bracket is nothing but a geometric series, infinite geometric series whose sum is 1 by 1 minus c. So it is less than or equals 1 by 1 minus c into modulus of xn minus 1. Agreed? So, sorry, here also c takes, c take outside from here. So it is c into that one. So it is c by 1 minus c into modulus of xn minus 1. That is what we look over here. So for any contractive sequence, x equals xn and its limit is x star, then modulus of x star minus xn less than or equal c by 1 minus c into mod xn minus xn. From here what do you get? Modulus of xm minus xn less than or equal c by 1 minus c into modulus of xn minus 1. Letting m tends to infinity. M tends to infinity means limit xm, that is x star. So it is x star modulus of x star minus xn less than or equal c by 1 minus c into xn minus 1. That is what we require. Agreed? So, dear students, now we conclude the second module here, and in next class let us discuss about the third module.